Up, everybody? Good morning. Happy Monday, or whatever day it is that you're watching this. But let's get right to it. So today we're going to talk about some two proportion z tests. We're going to use the same context that we used in the previous two videos about two proportion z intervals. So let's jump in. So here we go. So our goal, we know if we're going to try to estimate a difference in two parameters, try to estimate a difference in proportions, or later on means, we know we're going to use, once we see that keyword kind of estimate, we know the way we estimate the value of a parameter or the difference in two parameters based on sample statistics is using a confidence interval. So today we want to start to look at, without specifically estimating the difference in two parameters, how can I instead use a hypothesis test, in this case a two proportion z test, to determine if one parameter, one population proportion is significantly larger than another, or if there's just a significant difference between those two P's, those two population percentages. So today we want to look at our two prop z test. Let's do it. So first off, this is the same context that we've worked with our two proportion z intervals. So if you haven't watched the previous videos, pause it right here, and I would copy this context down into your notes there. Even though it's a little tedious, that's a good thing to do. And so the only thing that's different here is you can see that I've just phrased the question in two different ways. So anytime we're working with percentages, we can talk about rates, right? So like snoring rate is the same thing as percent of people who snore, right? So we can phrase it as the snoring rate for people over 30 or the percent of people over 30 who snore, right? Those are interchangeable, whatever. So I'm just showing two different ways to ask the same thing. We know on the exam, it's always a great idea to just pull the wording right out of the context when we're writing our conclusion. And that's always going to be something that I encourage. But if you feel comfortable, right, if the question was originally phrased the bottom way here, if you feel comfortable and you feel like it's easier, more concise to talk about a snoring rate for people over 30 instead of percent of people over 30 who snore, whatever, you could always rephrase that percentage, right? So a rate is a percentage in this case. All right, so got our two groups here, over 30, under 30, and we actually know the answer to this question, right? So is there evidence the snoring rate for people over 30 is greater than the snoring rate for people under 30? If we jump back to our two proportion z interval video with this same context, we created that two prop z in, and we can use that interval to answer this question. And we know, because our entire interval was either entirely positive or negative, depending on the order you subtracted, we know that our interval does suggest the percent of people over 30 who snore is statistically significantly higher than the snoring rate for people under 30. But let's approach that in a different way. AP exam-wise, we're not estimating a difference here, right? We're kind of looking for that evidence to suggest, and that's always a key phrase. When we want statistical evidence, statistical justification of some claim, that evidence, that justification, whatever that we're going to provide is going to be a hypothesis test. Process is going to be the same. So every hypothesis test, right? Same process. So we're going to jump in with our hypotheses, conditions, do some math, and then we're going to write a conclusion based on that p-value. Right, so none of that's different, right? We know the general idea. Got a little crazy here with some typos. That's all right. We'll fix those. Let's break it down. Conditions, we know the deal. Math, we can rely on our calculator pretty heavily as long as we can produce a p-value. We can write our conclusion. Worst case scenario on the AP exam, if for some reason we just draw a blank and we can't remember how to produce the p-value with our calculator, make one up. Make up a p-value, right? The math's going to be wrong. The p-value's got to be legit. It's got to be a probability. It's got to be between 0 and 1, but then we could use that made-up p-value. We should all be able to write our conclusion. So really the newest piece here, there's going to be some stuff that comes up with the math, but that's going to come up more in a future video, tomorrow's video. So for today, the new chunk here is going to be the hypotheses. So I'm going to switch over to the whiteboard here, and let's start to talk about how to write our hypotheses. So same deal as in the past, always, right? We want, oh no, who didn't put the cap on the marker? That's my only green. We know we want to write a null and an alternative. with a one proportion z-test, our null would say something like p equals some number, right? That's what happened with our one prop z situation. However, now, right, there's not one proportion anymore. Now, we got two proportions. So we're going to use a couple ways we could do this. We could use a P1 and a P2. If we're going to do that, we need a little key telling us which group is which. So if you're going to use ones and twos here, which I do like to do because the graphing calculator, when we go to put everything in the two prop z test, it's going to ask, right, everything to be in terms of ones and twos. So I like to, on my paper, use ones and twos, so then it kind of everything mirrors what I'm entering in the graphing calculator. But if we do that, right, we have to provide this key. Now, in the previous video, right, we made a little table when we read through the context. We summarized our information for our over 30, under 30 group, right? We listed kind of the given information, p hat 1, n1, we found x1 and all that, right? So if we do that, that table now is a little bit extra important because that's our insurance. Then we can, right, that's how we can use, you know, this can become our key. Let's jump to the alternative. We know the alternative hypothesis is based on the question. So there's a couple ways we can write these. Personally, I like the first option I'm going to use. We want to know if there's evidence that the snoring rate for people over 30 is greater than the snoring rate for people under 30, or is the percent of people over 30 who snore greater than the percent of people under 30 who snore. So if our group, right, 1 is over 30 and 2 is under 30, we want to know is the percent for group 1 greater than the percent of people in group 2, the under 30 group who snore. That's one way we can write our alternative. Now take it, you know, note here that if, right, if I switched the order, which is fine, right? There's no right answer as to which is group 1 and which is group 2. But notice now if I did that for my alternative, my alternative hypothesis is going to be affected, right? Because now we're going to want the under 30 group to be less than the over 30 group. So the 1 and 2 stuff, right, that's important. We got to pay attention to those details. So the alternative, just look at the question, right? Always. The alternative, by definition, the research hypothesis is what we're trying to prove. We're trying to prove the over 30 group has a higher snoring rate than the under 30 group. We're always going to assume, we're trying to show, right? We're trying to prove there is some difference or that 1% is larger than another. So we're going to assume kind of the, I don't know, the converse. I'm not even sure if that's the right word, but we're going to assume that there is not a difference, right? In a trial, we're trying to prove someone is guilty. We're going to assume they're innocent. We're going to assume they're not guilty. So for every single 2 prop z test, every 2 sample t-test you'll see coming in the future, even a paired t-test, the null is always the same idea. We always assume no difference. Or in other words, we're going to assume P1 and P2 are the same values, are the same proportions. This is the null hypothesis for every single 2 prop z test we're going to encounter in AP Stats. For a 2 sample t-test, it's going to look almost the same, except instead of proportions, we're talking means. So those will be mu1 and mu2, but the idea will be the same. So right there in blue and red, there we go. There's our null and our alternative hypotheses as long as we have the key. Now, another way you could go about this, and you do what works for you, we could really write this as a difference. So instead, if I want for the null, I can say P1 minus P2, right? The difference means subtract, right? If there's no difference, right, the difference is 0. There's no difference. So this is another option in blue here for how you could write your null hypothesis. You do what works for you, right? I personally like the top one, but like whatever, you do what works. So similarly, we could write the alternative hypothesis in terms of a difference. So instead of P1 greater or less than P2, now we can think about the difference. This comes back to some of the stuff we discussed with a confidence interval though. So now we have to think about if the over 30 group here, 1 is going to be the higher percentage, is P1 minus P2 going to give us a positive or negative? If P1, the over 30 group, is a larger percentage, a bigger number minus a smaller number is going to give us a positive difference. So this will then have to be greater than 0 to represent a positive difference. So for the alternative hypothesis, you kind of maybe got to think a little more. Maybe it feels a little more direct to just put the inequality symbol between these two, right? But whatever, again, you do what works for you, and then you do a little algebra, and it's easy to, turn these top ones into these bottom ones, or these bottom ones into these top ones, right? Just simple solving equation stuff. That's it. That's the deal for the hypotheses. Null, we always assume no difference. Alternative, we always look at what the question's asking, because that by definition is what the alternative hypothesis is showing, what we're trying to prove. Pay attention to the key, right? If you're going to use 1s and 2s in here, make sure you have a key showing which group is 1 and 2. And then if you're going to write it as a difference, right, the null is always going to look like one of these blue things. But if you're going to write it as a difference with the alternative, you got to think about, would that difference be positive or negative, which is really the reason I tend to lean more towards this top option. Kind of takes away that step of thinking about the difference between positive or negative. One last thing to bring up with the hypotheses, right? We don't have to use the 1s and 2s if we're worried we're going to forget a key. And again, on a side note, the reason I like the 1s and 2s is because that's what I'm going to see in my graphing calculator, right? When I go stat tests number 6 here, right, I'm going to see everything in terms of 1s and 2s, and that's what I'm going to see for my hypothesis or my alternative down here, right? Is P1 not equal to, less than, or greater than P2, right? So that's why I defer to this top method and into all the 1s and 2s. You don't have to use 1s and 2s. You can use little subscripts if you're worried about a key. We could say something like this: the proportion of people over 30 who snore is the same as the proportion of people under 30 who snore. Now, in this case, the order I was about to write wouldn't really have mattered, but just for the sake of consistency, right, I could do something like that. And then for my alternative, proportion for over 30 is greater than the proportion under 30. Those are lowercase p's. They don't really look like it because of the subscript, but that's it. So another option would be to use these subscripts instead of 1s and 2s, which then takes away the need for that 1-2 key, right? But again, you do what works for you. So that's the deal with our hypotheses. Next step we got over here, we should know this: conditions. Same deal, like we know the deal with the conditions. Like if you watch the 2 prop Z interval, you already checked the conditions. So flip back in your notes and peek at those. I don't know, if you have that stuff in your notes from the last video, I don't know that it's worth writing them down again. If you don't, take a minute, give it a pause here. You want to check the 3 conditions that we know for each sample, or for each group, maybe I should say. And then we always, anytime we have 2 samples, want to make sure that they're independent, which really just comes back to randomization, right? And again, we talked about that in the 2 prop Z interval video. Unpause. All right, so here you go. So conditions, right? This is the same exact slide we saw in that last video. So randomization, one thing I'll point out here is notice I chose, you don't have to do this, but I chose to kind of lump the independent groups, right? So I'll say random and independent groups condition with randomization, because those things kind of, connect. So there I've got 2 conditions in this top part. Below that, next down here in bold, we got our 10% condition and then our success failure condition. We're going to talk about something going on here. If you check the conditions like this on the AP exam, it's like not really that big of a deal. Like I'm pretty sure this is essentially correct. I remember double checking that in some rubrics last year. But what I just underlined down here in red, or now I'll throw in some purple, think about the null hypothesis we just wrote. All right, so that's it for our conditions. So the math. If I'm taking the AP exam, the first thing I'm doing, right, is I'm reading the question, maybe making that table, writing my hypotheses, banging out the conditions, unless it says assume the conditions for inference have been satisfied, and then I'm grabbing my graphing calculator. So take a minute right now. Stat tests, go down to number 6 there, that 2 proportion Z test. and enter all the information, choose the right alternative, right? Try it on your own first, and if you do it right, you should get a p-value when you're done of like 0.003. Give it a quick pause. Jumping ahead here. So our two prop z-tests, I chose, right, I stayed consistent with the last video, so I kept my over 30 as group 1 and under 30 as group 2. You can think about if you were to switch groups 1 and 2 here, how would that then affect this alternative? That's actually a slide I've got coming up just to make us think a little bit. And so here we got this, right? So if I'm taking the AP exam, I'm copying this calculator screen. Now I'm definitely copying, right? We always need the name of the test or interval. We need our z-score, and this is a p-value. We've got our p-hats here. Maybe you copy these down, maybe you don't. Like you might have made that table with all the 1s and 2, right? Group 1, group 2, p-hat 1, x1, n1. You know, then you don't really need to copy this again. We've got our n's here, and then we've got this. So everything on the screen should be familiar to some, to some degree. We've seen z-scores. We know what a p-value is right here. We've worked with the p-hats and the n's when we did the interval. But this p-hat with no 1 or 2, that's not something we've seen. That's called p-hat pooled. So we're gonna have one more video about two prop z-tests, and I'm gonna focus, really kind of zone in on the p-hat pooled stuff and how that connects to the math. But let's try to go through, like if I'm taking the AP exam, that's my approach to this video. I write the hypotheses, I check the conditions, I put everything on my calculator, I'm gonna copy my calculator screen, and then I'm gonna go right to the conclusion. If I have time, I might come back and fill in some formula stuff, and that's what the next video will be about, right? If I'm taking the exam, I'm just copying this calculator screen. And of course, we want to focus on understanding, right? You guys know that that's what I'm all about. I'm not gonna have us mindlessly do stuff, but for the sake of, kind of getting through it with this weird environment, right? Copy our calculator screen, we got our p-value. Every person who's watching this video, at least if you're from my class especially, right, we should all see this p-value. Like you should already have an idea about what the conclusion is just from looking at that value. Again, if you, for some reason, right, like made a mistake here, if you got the wrong p-value, sure, you're gonna get incorrect for the math section, but you can still get essentially correct for that conclusion, right? So we should never, ever, ever get anything but essentially correct on our conclusion, because it's the same deal as always. It's the same as every hypothesis test we've been writing about since the beginning. We'll come back to this math part with the test statistic and the sketch. That's coming in our next video to focus on the math steps. But so for the conclusion, right, same deal as always, right? So everything on the screen now, right, those just old generic notes for us. P is low, reject the null. Right, so if our p-value is less than alpha, we're going to reject the null hypothesis. Looks like I got crazy and accidentally used an A with some, what happened here? What is this? I didn't even notice that. Pretend these A's aren't there. That's my bad. But if p-value is less than alpha, we're going to reject, oh, that was supposed to be an arrow. Reject the null, which means there is evidence. P-value is greater than alpha, we fail to reject the null, right, which means there's not evidence of the alternative. And then as I mentioned earlier, we can copy the wording from the context. So take a minute. I'm just bringing up the original question. Our p-value is actually 0.0003 if I was better at rounding. Don't worry, I'm better at stats than rounding. Is there evidence to suggest the snoring rate for people over 30 is greater than the snoring rate for people under 30? Write it up. All right, let's check it out. So nothing new here. That's the biggest thing I want you to take away. You could write a conclusion for every single hypothesis test for the entire, right, all of AP statistics after we did one. So at the top, I've just phrased this two different ways, right? If you happen to look back at your notes, if you had written the percent of people over 30, under 30 wording, maybe you wrote this conclusion. If you use snoring rates, right, this. Notice for me, I said that the p-value is below any common alpha level, right? That 0.01, 0.05, 0.10, those three common alpha levels we choose, right? And that wording is fine. But if you don't feel comfortable with that, you could just choose one, right? And I know a lot of us would just pick 0.05, right? Like when in doubt, pick 0.05 for your alpha level or 95% of your confidence, not for any mathematical reasons, just because it's one less thing to remember. But so if you wanted to pick an alpha level, that would be fine too, right? Because no matter which one you pick, right? Whatever, we're all going to reject the null, which is why I can say this up here. So I can say p-value below any common alpha level, so we reject the null, or I can say the p-value 0.003 is less than an alpha level of choose 1.05, so I reject the null. From there, right, there either is evidence to suggest the snoring rate for people over 30 is greater than the snoring rate for people under 30, or I can choose the wording, there is evidence the percent of people over 30 who snore is greater than the percent of people under 30 who snore. My advice, copy the wording from the question, right? There is or is not evidence to suggest the snoring rate for people over 30 is greater than blah, 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 right? So that's it. So we should be able to procedurally get through a full 2 Prop Z test if it's on the AP exam. Hypotheses was the big new thing here. Conditions, we could do the same way as the interval. We will touch on that a little bit. We got to talk about how that connects to the assumption in our null. The math, we can copy our calculator. We do need to develop a better understanding of where those numbers are coming from, specifically that Z-score, and connect that to our sketch of a normal model. We'll focus on that in our next video. And then the conclusion, same deal as always. So, a few more things. First off, I mentioned earlier, right? Some people might switch which is group 1 and which is group 2, and that's what you can see going on here. Forgot my little pause picture, but take a minute, pause this. If we're going to enter the under 30 as group 1 and over 30 as group 2, what would be the correct alternative? And then regardless of which one's correct, if you chose an alternative of less than, what would the p-value be? And if you chose an alternative of greater than. And so remember, in this case, we're starting with p for like under 30 and then p for over. So pause. Hopefully you told me that we would then want proportion for under to be less than that of over. So we should now choose the less than symbol. And if we do choose the less than, we're just going to get the correct p-value of 0.003, right? If you kind of picture this, sorry, I'm doing this with the mouse, right? We're kind of shading this tiny little sliver over here. But if I accidentally chose greater than still, right, now I'm going to shade like all this to the right. And so I'm going to end up with 0.997. That was pretty much the worst 3 numbers right here ever written with a mouse. So we'll just do that so you can actually read it. Right, so that's what's going there. So just something to make you think. How about one more to make you think? What if we change the question? So the only change is what's in red here. So what if instead of asking if one snoring rate was larger than another, the over 30 larger than the under 30, what if we asked if there was a significant difference in snoring rates? What would change? Give it a pause. And hopefully we realize here the big change is going to be, now we're not just going to have, right, so I'm going back to when we did 1 greater than 2, and the size of this region was 0.003. That was our p-value. Right now, we're not just going to have this one-tailed test. And if you flipped the groups 1 and 2, like on the last, on the last side we just saw, a one tail would be on the other side. But now if we change to this wording, we're not going to have our one-tailed test. Now we're going to have our two-tailed test. This would also be 0.003. And so if we do this, our sketch changes. Whoa, got crazy there. If we do this, our sketch changes, but also, right, our sketch changes to reflect our two-tailed test, and now our p-value is going to be 0.006. Right, we're going to have to double that for both tails. All right, let's keep rolling. A couple more slides and we're done. Type 1 and type 2 errors, right? They're not going away, but they're the same exact thing. Same definition, right? Null. In reality, the first one, the null is true, but our test suggests the alternative. Type 2 error. In reality, the second one, the alternative is true, but our test fails to show that. Be careful with the type 2 error. Don't say in reality the alternative is true, but our test says the null is true, right? We can't do that because we can't prove the null, right? So with type 2 error, when we write it up, we got to be careful with that wording. Make sure we don't accept or say we're proving the null hypothesis. But the ideas are the same. Take a minute, pause it. And I want you to try to write up what would a type 1 and a type 2 error be in this context. No consequences here because we don't have any information about that. Pause. See how you did? type 1. So I've just written them again in two different, like using two different wordings. That didn't sound smart when it came out of my mouth, but I don't know if it was even right. Two different. I phrased these in two different ways, talking about the percent of people over 30 who snore, or the snoring rate. Again, right? Whatever you do, whichever one works for you. And so there we've got our type 1 and type 2 errors. All right. So then we'll still have questions about power and alpha and beta. Right? All those concepts hold true. Right? Increased alpha, beta decreases. Alpha is the probability of type 1, beta is probability of type 2. Increased sample size decreases both types of error, right? All that good stuff. So that's it for today. Your homework for tonight is a 2015 free response here. Once we see, I just immediately look down, right? And once we see this phrase, statistical evidence, that should have us thinking about something. We see an alpha level here. That should be a pretty clear indication as to what this might be. But so tonight, please do this 2015 free response. Pop it up in Google Classroom. I'm going to put up a rubric, score it, first little practice, and then that's it. So good luck. That's pretty much it. Good luck. Go Giants.